Alrighty, so today we're going to really start diving into rational expressions, and we're going to start by talking about multiplying and dividing rational expressions. So the first thing we've got to figure out is what are rational expressions, okay? A rational expression is a polynomial divided by or over another polynomial. So then the next logical question is, what's a polynomial? A polynomial is a combination of terms that have been added together. So an example would be 3x squared plus 7x plus 2. That's a polynomial. More specifically, how many terms does that have? 3. So technically it is a trinomial. But that is a type of polynomial. Over 4x to the 5th plus 7. That is also a polynomial. Yeah?
So if it was like 3 plus 7 plus 2, would that still be a polynomial?
Technically, a constant is still a polynomial. It's just a trivial case because it's the power of x that it goes with is just 0. It'd be technically like 7x to the 0 power. So that would just be 7. So yes, technically it is a rational expression if it's like 7 over x, but we're going to be focused on a little bit different ones. Okay? So polynomial over another polynomial. When you want to simplify a rational expression, the first thing you're going to do is factor the numerator and denominator completely. So factoring is going to be an incredibly important part of this unit. Okay? If you feel, shaky about factoring, if you aren't sure you ever got to the level of mastery you should have, it's going to be really important that really soon you practice. Whether that's looking up some YouTube videos or some Khan Academy lessons and practicing, whether that's going back over our old notes and quizzes, things like that, you've got to gain your mastery of factoring, okay? Your second step is going to be to identify any x values that make the expression undefined. The big idea here is in a rational expression, you're going to have a variable in the denominator. That's different than many of the things we've graphed or solved before. That variable being in the denominator causes, at certain points, the expression to be undefined. Why?
Because it can't be equal to 0.
What can't?
The denominator.
Good. The denominator can never be equal to 0. We are never allowed to divide by 0. So we are going to have to always identify any x values that aren't defined. Any places where the function's not defined. And our last step is going to be to cancel out common factors. Now, that word factors is incredibly important. You are only ever allowed to cancel out factors. Factors are the things that multiply together to give you your original expression. You are only allowed to cancel factors. I'm going to say that so much that you're going to want to throw things at me. Okay? Please don't. But the reason is that I want to say it so that it gets stuck in your head. So when you're at home on your homework or when you're working on a quiz or a test, you hear me saying over and over again, you can only cancel factors. Okay? Have to cancel factors. That's the only thing you can cancel. Yeah, I'll show you. You'll see lots of examples as we move forward. Okay, so I want to work this little tiny warm-up here. 5/2 times 8/10. And I want to kind of work it in this process. So the first, I know you know how to solve this. You can simplify and multiply. But I want to show you kind of what we're going to be doing. So take your numerator of 5. Can I factor that at all? No. How about 2? No, it's already as factored as it can be. What about 8, though? Are there any other prime factors I could list out instead of 8? Okay, 4 and 2, but then if I factor out 4 again, it would give me 2 times 2 times 2. Those are the prime factors of 8. What are the prime factors of 10? 5 and 2. So now that we have everything factored, these are all the factors, they're being multiplied together. Now you are allowed to cancel factors. So now I can cancel this 5 with this 5. This 2 with this 2. This 2 with this 2. So what's all that I have left? 2. So the reason that your rules for simplifying work are because you're canceling factors. You're canceling out prime factors. Okay? All right, let's simplify numbers 1 and 2. We're not going to start multiplying or dividing yet. We're just going to simplify. So write down this first one, x squared minus 2x minus 3 over x squared plus 6x plus 5. So we start off by factoring the numerator and the denominator. In this case, my x value, my a value, the value in front of my x squared is 1. So I can do the shortcut factoring, right? I can just come up with my factors of -3 that add up to -2. What are those? -3 and +1 over, how about factors of 5 that add up to 6? So x plus 5 times x plus 1. You want to stop here and think about what x values would cause this expression to be undefined.
-5.
Yeah, so you think about setting each factor equal to 0 and figure out what x values would cause each factor to be 0. So this first factor, if we set x as -5, we would get 0. So we know x can't equal -5. And x also can't equal -1. Everyone okay? You think about what would make each factor 0. So if I plugged in -5, I'd have a factor of 0, which would make my denominator 0. And you can never divide by 0. Okay? Now you can cancel any common factors. What common factors do I have? Okay? These are factors. I can cancel them. Was I allowed to cancel these x squareds? No, those aren't factors. Only when they're all being multiplied are they factors. So I end up with x minus 3 over x plus 5. That's my simplified version for all x values except -5 and -1. All right, look at number 2. Go ahead and jot it down. Okay, first thing I want you to notice, there is no benefit to squaring x minus 4. It's going to take you further away from your goal rather than closer to it. Because our goal is to get everything as factored as possible. So instead of writing x minus 4 squared, could I write this as x minus 4 times x minus 4? Yeah. Over, how does x squared minus 9x plus 20 factor? Yeah. All right? What x values would make the function undefined? 4 and 5. So we know that x cannot equal 4 or 5. Do any of our factors cancel? X minus 4. So what do we end up with? For all x's, except x cannot equal 4 and 5. All right. Look at number 3. Notice in number 3, we don't have trinomials being added or subtracted. We just have a bunch of factors. Everything is being multiplied together. So these work just as we've seen them work in the past. We can simplify and multiply. Right here? Yeah. Yes, that's x to the 5th.
Back on number 2, how come x couldn't be 4? Like in x minus 4 over x minus 4.
Okay, so back in number 2, the reason x can't equal 4 is because at some point in this expression, if you plugged in 4, you'd get an undefined situation. If I plugged in 4 right here in my original, I end up with 0 in the denominator. And if at any time an x value gives you 0 in the denominator, then the expression is undefined.
So then, but it would work for the x minus 4 or the x minus 5.
But at some point in your simplifying, if you any value that you could plug in that would give you 0 in the denominator, you have to exclude that value. That's why you can't just look at your final answer. You have to look at all the steps in between. Okay? Okay. So on number 3, we have nothing being added or subtracted together. Okay? So instead, we can go ahead and just approach this like we have in the past. We can simplify each fraction and then multiply. You don't have to follow our special rules here because every single part of this is a factor. 12 is a factor, x to the 5th is a factor, y squared is a factor. So let's stop here for a moment. What are the restrictions on our variables? What can x and y not equal? 0. Okay? Now, if you wanted to, you could multiply the tops and the bottoms and then simplify. But I like to simplify first so that my numbers are smaller. So let's look at my first fraction. 12 over 6, what does that simplify to? 2. X to the 5th over x squared. Y squared over y to the 4th. Yeah, y to the 2nd in the denominator. Times 9 over 3. 3x cubed over x squared. Y over y cubed. Good. Now when we multiply, remember we multiply across the top and we multiply across the bottom.
The y squares cancel each other out.
Nope, because we multiply the tops and then we multiply the bottoms. So 2x cubed times 3x. Good. Over what's y squared times y squared? Good. For all variables except x and y equal to 0.
Even though x is yeah, because couldn't x be anything? in this
Okay,
situation?
okay. So the idea is, what I was explaining to Blake just a minute ago, was that if at any point in the expression a variable makes the denominator 0, you must include it in your restriction. So at the very beginning, if you included 0 for x, you'd have a 0 in your denominator, so it would make it undefined. You can't just look at the final answer. You have to look at every stage. Okay? All right. Here's number 4. Yes. All right, so we start by factoring everything as much as possible. How does 2x minus 2 factor?
2.
2 times x minus 1. Over, what about x plus 4? Okay, so we leave it as x plus 4. Times, what about x squared minus 16? Good. Difference of squares. X minus 4 times x plus 4. Over x squared minus 3x plus 2. Okay, so x minus 2 and x minus 1. Stop here and think about x values that make your expression undefined. So x can equal negative 4, x can equal 2, and x can equal 1. All right, can we cancel any factors? X plus 4. What else? Your x minus 1. So we end up with 2 times x minus 4 over x minus 2. But x cannot be negative 4, 1, or 2. You do not have to distribute this 2. If you really want to, you can. But in my opinion, if you can stop, stop. Can only cancel factors. So that wouldn't be able to work. Yeah. No, what you're doing is to find the undefined values, to find the x values that are undefined. Take each factor and think about what would cause it to be equal to 0. So you think about, okay, when is x, we can never have x plus 4 equal to 0. So we can never have x equal to negative 4. That's where we're getting it for each factor. Okay? All right, look at 5. Go ahead and copy that down. Okay, so we start factoring. 2x plus 14, what can I pull out? It's going to be 2 times x plus 7 over, what can I pull out of 2 times x squared minus 50? So I'm left with x squared minus 25. Yeah, what do you notice about that? That's a difference of squares. So you can rewrite it, or you can just kind of write under here, what does x squared minus 25 factor into? X minus 5 and x plus 5. All right. What about 8x plus 40? Pull out an 8. What do I have left? X plus 5. Over, let's see, 6x plus 42. 6 times x plus 7.
Would you simplify the 2 over the 2?
We will, yeah. So first, let's go ahead and identify x values that make this expression undefined. What do you think? Negative 7, that is 1. Negative 5 and 5. Good. All right, now we can start canceling. So as we already heard, the 2 over the 2, are those factors? Yeah, they're being multiplied, so those can cancel. X plus 7 over x plus 7. How about this 8 and the 6? Yeah, you can reduce that. What's 8 over 6 reduced to? 4 over 3. And then this x plus 5 cancels with this x plus 5. So what do we have left? Where x does not equal plus or minus 5 or negative 7. Because when this x squared minus 25 factored into x minus 5 and x plus 5, I could, by plugging in either 5, I would get 0. All right, let's look at number 6. All right. So that first numerator that I'm going to try and factor, 2x squared plus 5x plus 2. Can I use my little shortcut on that? No, why not? Good. Your a value, the number in front of x squared, is not 1. So what I would recommend anytime you need to factor something out is kind of just go off to the side of your paper or go under the problem and actually write it out. Don't try and do it in your string of simplifying. It'll get too complicated. So I'm going to just go over here and I'm going to try and factor 2x squared plus 5x plus 2. So remember, you multiply your a value and your c value. So that's 4. What factors of 4 add up to 5? 1 and 4. So then we have 2x squared plus x plus 4x plus 2. Remember, you group the first two terms and the last two terms. So I can pull out an x. I'm left with 2x plus 1. And I can pull out a 2. And I'm left with 2x plus 1. So I get x plus 2 times 2x plus 1. So that became this numerator right here. All right, what about that denominator? 4x squared minus 1. Good, that's a difference of squares, so 2x minus 1 times 2x plus 1. Now what are we going to need to factor? Yep, I've got 2x squared plus x minus 1. I can't use my shortcut for that one, can I? Nope, so I've got to go a long route. Negative 1 times 2. Negative 2, so I'm looking for factors of negative 2 that add up to positive 1. Good, 2 and negative 1. So 2x squared plus 2x minus x minus 1. I can pull out a 2x. I'm left with x plus 1. And what can I pull out of this? Negative 1, and I'm left with x plus 1. So I get 2x minus 1 times x plus 1. All right, what about the denominator of that second expression? Can I use the shortcut there? Yeah. So I've got x squared plus x minus 2. What would that factor into? X what?
X minus 1 times x plus 1.
Good. X minus 1 times x plus 2. Any questions about the factoring there? Okay. So let's define any x values that make this undefined. Think about setting 2x minus 1 equal to 0. What can x not here equal? 1/2. Or negative 1/2. Good. And then 1 and negative 2. All right, can we cancel anything?
Yes.
X plus 2's cancel. 2x plus 1's cancel. 2x minus 1's cancel. What are we left with? plus 1 over x minus 1, where x does not equal plus or minus 1/2, negative 2, and 1. If you want to list it from smallest to greatest, that's great, but if you want to put plus or minus and that kind of throws it out of order, that's okay too. Questions on that? All right. Before we dive into number 7, I want to remind you about something. When we divide fractions, so if I have a over b divided by c over d, tell me how to do that. Okay, good. So you keep the first one, a over b. What do you do to the division? Change it to multiplication and then flip it. So keep the first, change the sign, flip the second. Keep, change, flip. All right. Same idea here. We're dividing fractions. So we're going to keep the first fraction. Change the division to multiplication, and then flip the second fraction. So we keep the first, change division to multiplication, and then flip the second. All right, will you please take a second and get everything as factored as it possibly can be? You're done with your factoring. Check up here and see how you did. So it's the exact same to write these as a separate fraction times a separate fraction. But remember, when we simplify this, we multiply across the top and we multiply across the bottom, right? So I just went ahead and decided to have all the factors be multiplied across the top and across the bottom. Whichever way makes more sense to you is totally fine. All right, let's list the x values that make this function undefined. 0. Where do we get 0? Yeah, 2x is a factor. You got to think about that. Now, what I want you to think about anytime you divide, there's one little extra thing you've got to remember. Originally, 2x squared minus 10x was in the denominator. You see that? Yes. We ended up flipping it, but at one point in this problem was that in the denominator. Yes. So we have to think about anything that would make that undefined. So kind of just follow your path. 2x squared minus 10x factored into 2x times x minus 5, right? So do we already have both the values that make that 0? Right. It won't always happen that way, so you might have to add in an extra value. So you want to remind yourself you have to check every stage of the denominators. From the original to the end. I'm sorry, Blake?
Where do you get the 0?
The 0 comes from this 2x. 2x is a factor. If you set 2x not equal to 0, x cannot equal 0. All right, now can we cancel? All right, so x minus 4 and x minus 4 2 x's and 2x, and x minus 5 over x minus 5. So we get x plus 2 over x plus 3, where your x's can't equal negative 3, 0, 4, 5.
Why can't it have not as negative?
I'm sorry?
Why can't x not equal negative 2?
The reason that negative 2 isn't included is because it's okay to have 0 in the numerator of a fraction. 0 divided by anything is just 0. You're just not allowed to have 0 in the denominator of a fraction. All right, let's keep going. Let's look at number 8. Yes, that's x cubed minus 125 over 5 minus x divided by x squared plus 5x plus 25 over 8x cubed. So we're dividing two fractions. So we always are going to start by rewriting it. Keep, change, flip. Keep the first fraction. Change division to multiplication. Flip the second fraction. Everyone okay with that? Okay. How does x cubed minus 125 factor? Difference of cubes. Good. Remember, difference of cubes is SOAP. You'll always have AB, and then A squared, AB, and B squared. What does the SOAP stand for? Same sign, opposite sign, always positive. Okay? So x cubed minus 125 would give us x minus 5 times x squared plus 5x plus 25 over 5 minus x. Does 8x cubed? Can we do anything with that? No, just leave it as 8x cubed. We'll talk about that part in just 1 second. Over x squared plus 5x plus 25. All right, what's one thing we notice?
We can factor x squared.
So let's think about it. X squared plus 5x plus 25. Does that factor?
Yeah.
Are there factors of 25 that add up to 5? No. So can I go ahead and cancel these then? Okay. Now some of you might be looking at this x minus 5 and this 5 minus x and thinking those are really, really similar. Okay? There is a way to manipulate that to make them cancel. So the first thing you would do is pull out a negative from this 5 minus x. If I rewrite this as negative 1 times, that would give me negative 5 plus x. Have I done anything illegal? Nope. I've just rewritten it without that negative. Okay, and how can I rearrange negative 5 plus x? X minus 5. Why is that beneficial to me? Yeah, now x minus 5 and x minus 5 cancels. Does this negative 1 go anywhere?
No.
Stays. You got to remember that negative 1. So we're left with this negative 1, and we're left with this 8x cubed. What's 8x cubed over negative 1? Negative 8x cubed. For x values except, where are you getting 0? Good, because originally 8x cubed was in the denominator. So x cannot equal 0, and what else? 5. From right here, if I plug in 5, I would get 0. Did x squared plus 5x plus 25 factor? No, so we don't know where those zeros are. So we don't have to worry about that. Okay, but think, -1 is a factor, you're right, but when you set -1 equal to 0, there's nothing that can make -1 0. Okay? All right. We're skipping number 9. Look at number 10. Yeah.
Why can't you have me set that to 0? Like when
You don't need to worry about it. You would have to use the part that you don't have to worry about it. All right, so look at number 10. Okay. When you've got more than 2 expressions being multiplied or divided, it's important that you remember that that division sign only applies to the expression directly after. Unless there's parentheses grouping stuff together, this division only applies to this expression right here. So this 2x plus 6 over x is the only expression you're going to flip. Okay? So let's keep our first one. Change division to multiplication. Flip the next one. And then what happens to that x plus 1? Stays in that numerator, x plus 1. You can put this over 1 if it makes more sense to you to do that. All right. So how does x squared plus 2x minus 3 factor? Good. What about x squared minus 1? X stays by itself. What about 2 times x plus 6? 2 parentheses x plus 3. And x plus 1, you can envision it over 1. All right. What can x not equal? Plus or minus 1. -3. Anything else? Good. Where are you getting the 0? Yeah, that original x. All right, x plus 3's cancel. X minus 1's cancel. X plus 1's cancel. What are we left with? Over 2. Questions on that? Okay. On your homework tonight, you may cut numbers 5 through 7, numbers 11 through 13, and number 36 through 39. Some of the homework problems will say, identify any x values for which the expression is undefined. That's when you'll do like we did, where we say x not equal to blank. Some of the homework problems will say, assume all expressions are defined. In that case, you do not need to tell me where they are undefined because you're assuming that they are. So go ahead and cut these numbers, and I will project your homework to get started on.